Alright, Crewton Ramone, math.com. We have a quick screencast. Or actually, I don't think it's going to be quick. Screencast on problem solving. More problem solving problems. More story problems that you need to be able to do with your students. And of course, we're going to keep it simple. And you'll see as we go further, there's more complex and difficult problems on the password protected problem solving page. To start off, this doesn't look like much, but this is a 11-year-old student that enjoys building. We've come to an agreement where he gets to build and play as long as he's doing his work. So here is the foundation, and of course, even while he's building and playing, he's still having to build 13s, 12s, and 11s. Those are add-ins, right, that he's working on there. And this is the first story. Okay, so let's get going here. So as a review, we started off doing some negative factoring. So there's x squared plus 3x minus 40 upside down. And I just gave it to him as a problem to start off. And as he worked on his problems, he, well, like I said, you can see it's, he's got some men out, and the walls are starting to come up, and he's doing his work in his book diligently. Now, how's this? This is an 11-year-old. This is his review. And notice that there's no pictures here, just symbols. So here's x minus 7, x minus 3, and there it is, x squared minus 10x plus 21. And let's see here. So he's got all of these guys going well, except for the part that this is supposed to be 15 over here. And let's see. That's just a minor mistake because he knows that 3 times 5 is 15. But anyway, there he is doing, pretty high school algebra, basically, right? Factoring negatives. And we're going backwards. In other words, we're taking the factors, and he has to give the whole rectangle. So these are the sides. Here's the whole rectangle. So basically, distribution. This times this equals that. And he understands. It's easy. It was a review. He whipped right through it. We went on to other stuff. And there's his house taking more and more form and shape. You can see the various sides and so forth. He built a staircase. And this is sheerly just for fun. Just having a fun time building a house while he does his work. Alright, so now here is a story problem. And you can find this. There'll be a link to one of the blog posts that has lots of story problems like this. Once you can do these kind, you can do them all. And eventually I'll get around to making a screencast that covers every single one of those problems. But here is the simple story. It takes about 4 hours to travel 16 miles downstream with the current, and 8 hours upstream. 4 hours for 16 miles going with the current downstream. Same trip, same boat, same path, same river. Going back up, it takes 8 hours to cover those same 16 miles. What's the speed of the boat, and what's the speed of the current? In other words, what's the speed of the boat in still water, and how fast is the current going? That's a traditional textbook problem out of algebra. And it gives kids headaches, and it's hard for a lot of children, and you'll see that actually it's super easy. Super easy. Okay, so here is boat, and here is current. Boat and current. And these are on their side, so we don't know what they are. This could be, these are, if it's not 7 and 5, these are just, we're using them as x's and just to visualize. Here's the boat plus the current, the distance. And how many of them do we have? Well, we have to make 4 of them because it's 4 hours. And putting them along, right, to make it, a story problem where we go along like this, we don't have enough room. It takes up too much space, especially on the way back. It's going to take up way too much room. So we turn it into a rectangle. Why? Because rectangles facilitate counting. So here it is a rectangle. 4 hours worth. And here we know this side is 4. But again, these are x's. We don't know how much this is. This is boat and this is current. So all we know is this side is boat and current, and this side is 4. But we do know that the whole thing is 16. So if we have a rectangle where one side is 16, or excuse me, the whole thing is 16 and one side is 4, then that means the boat plus the current must also be 4, right? And then over here, we have the, and see if we would have got all those out, and actually we did, you'll see that in a second. The whole rectangle is 16, one side's 8, boat plus current must be what? Well, it has to be 2, because we know. We just form it into a rectangle and do some simple division. See how easy this is? So there he is, his first time, he says it's equal to 4 and equal to 2, and once again, just control of error. It's absolutely correct, but it's this side that's 4, and it's this side that's 2. So this would make no sense, technically, because if the whole rectangle is 16 and one side's 8, this side also has to be 8, not 2, right? And this side would be 4, and this side would be 4. This side would be 2, and this side would be 2. So that has to move down here. So all we did was just simply correct his labeling so that he could see b plus c really is the same thing as 4, and b minus c really is the same thing as 2. Very simple. So now what do we do? Well, if you look at the problem solving that we've done from before with 10 apples up on top, he understands how to isolate a variable by using hero 0. So there's b plus c equals 4, b minus c equals 2. We just add these two guys together, and the symbols are sloppy, but there's 2b equals 6. So what does b have to be? Well, b has to be 3. And now we can plug that into the equation, and we can see that c must be 1, because b plus what is 4? Well, 3 plus 1 is 4. And 3 minus 1 is 2. Super easy, super simple. And now we can start understanding how to do these problems and visualize how they work. So anyway, there it is, all written out. And oops, we don't have a good picture of the block set up here. Let's see. Yeah, there you go. Okay, so there's the problem. 4 hours, right? Takes them 4 hours to go 16 miles with the current on the down trip. On the way back up, it takes 8 hours. They go 16 miles, and so, another way to say this is it takes twice as long. You can word the problem however you want, but basically, it takes about 4 hours to go downstream with the current, and it travels 16 miles, and that same boat on the same river travels 16 miles back up, and the trip takes 8 hours. Now, there's a visualization of the down trip, and here's the visualization. There's 8 of them on the up trip, and we could make this going, a lot longer this way, right? And sideways, line them up, but there's no room and it takes too much space. But sometimes with little kids, you might want to do that on the floor or something if you have enough space to do it. And over here, you can see the top view of the house that he's building as we're doing the problems. So anyway, here are the calculations using the rectangle to organize the thought. And there's the symbols. We have a nice combination of the two. There's the problem, and it has been solved. Boat 3, current 1. Simple. Okay, so now here's a new problem. It takes 4 hours to go downstream 24 miles, and it takes 6 hours to come back that same 24 miles. What's the speed of the boat? What's the speed of the current? And so we just arrange it the same way. Right? 24, one side's 4, the other side has to be 6. 24, one side's 6, the other side has to be 4. So b plus c is 6, b minus c is 4. Hero 0, we get 2b equals 10. So now we have boat is moving at 5, and the current is still just lazily moving along at 1. And the way we do that is by, once we find what b is, we put it back in there, and we can figure out that 5 plus 1 is 6, and 5 minus 1 is 4. Very simple, just solving for each variable. Alright, by isolating. And there it is. Again, we have, just using these, 4, right? One side's 4, and here's boat plus current. And then on the return trip, here's 1, 2, 3, 4, 5, 6 of them, right? And here's just boats minus current. And again, the blocks don't mean anything. These aren't 7s and 5s or 10s and 6s. We're just using them to visualize because they're X. We didn't know how much B and C were or how much B minus C was. We just knew that we had 6 of them and 4 of them to visualize and organize our thought using the manipulatives. Okay, so now last problem. 2 hours to go 30 miles. We're zipping along. And then we come back and it takes 6 hours, 3 times as long, to cover the same amount of distance, 30 miles. What's the speed of the boat? What's the speed of the current? Alright, so same rectangles. By now he's not even getting out blocks. He just fills in the rectangles. So here's 30. One side's 2. The other side has to be 15. Here's 30. One side is 6. That's supposed to be a 6, not a C. The other side must be 5. So we know boat plus current is 15. Boat minus current is 5. And we wind up with, you can see here, he's writing it out. Well, what does it have to be? Well, we have 2B equals 20, so B must be 10, right? And the current must be 5. And it works both times, because 10 minus 5 is 5, and 10 plus 5 is 15, so we figured it out, what the speed of the boat and what the speed of the current is. Super easy. This is all you got to do. I mean, and like I said, once you can do these, now you can change it around to making, airplane problems where you're traveling 3,000 miles in 6 hours, and just change it around and put some zeros on it. So now I have a 2-hour trip with the wind, and make it 3,000, right, in 2 hours, and well, maybe 300 would be better, because 3,000 isn't quite realistic, because we don't have any planes that go that fast that civilians can get on. Anyway, and then 6 hours in the return trip for 300. Wow, that must have been a pretty stiff wind, right? And everything's going to have an extra 0 on it. And you can do them for, anyway, you'll see. Once you can do, here's 3 examples. You can do all the examples, because it's just the same thing over and over again. Boat plus current, boat minus current, forming the rectangles. Makes it super easy and fast for any kid to do this. And little kids can do this too. Crewton Ramone's houseofmath.com for more.